go through our geometry view of lessons 1 through 50. Obviously, we're not hitting all 50 lessons, but it's just a kind of a scattered section of what all is going to be covered. This question number 1 comes from lesson 24. What we're looking at here is algebraic proofs. I know that we're not huge fans of proofs, but we do see them on the test, and we see them show up in largely this fashion, if I can get that whole question on there. Mrs. Tibbs has 26 feet of fencing to build a rectangular play area for her rabbit. She wants to have the largest play area possible, but it can be no more than 8 feet long. To find the width of the play area, she uses the formula that the perimeter will be twice the length plus twice the width, where P is the perimeter, okay, L is the length, W is the width of the rectangle. Fill in the missing justifications, okay? Keeping in mind, what does it say? It can be no more than 8 feet long. So they start off with the given, okay, we know that. Notice, where does the 26 come from? Well, it says that she only has how much fencing? 26 feet. So that's a limitation that she has. Okay, so she's only got 26 feet of fencing. We know that our length, notice that she substitutes in 8 for length. Why did she substitute 8 in for length? Right, it can't be any more than 8 feet long, so we have another constraint, plus twice the width, okay? She wants to have the largest play area possible. It can be more than that, all right? And then she uses that particular formula, so we're going to stay within that formula. So what we want to put in for our reason, okay, we've got our statement on the left, our reason on the right. What have we done in this first step here? What we've done is substitution. Again, I don't promise to have spelled that correctly because I feel like I have too many T's, but it seems right to me. Okay, substitution property of equality, that would work there. You can notice if you scroll down, you're probably going to see substitution show up in there. All right, from here on, well, you see what they do next. Now we're just following the math on down. 26 remains 26. In the next step, they take 2 times 8 and get to 16. They bring the 2W down. So all we've done there is simplify. Okay. If we're trying to solve for W, everything from this point on is just things that we would do to solve for W. So isolating W. So she subtracts 16 from both sides to get 2W by itself. Subtraction property of equality. All right. Then the next thing that we see is simplification. Taking 26 minus 16 is going to leave us with 10 equals 2W. And then from 10 equals 2W, we see this step right here. Okay, what is taking place there? Somebody besides Brady, Austin. Division property of equality, because I'm dividing by the same thing on both sides. Okay, division property of equality. All right, so what we get is 10 divided by 2 equals 5, and 2W divided by 2 equals W. And then finally, they just switch it. All right, so we did get the division property of equality, okay? And then the garden is going to be 8 feet wide. All they did here was the symmetric property of equality allows me to move things across, okay? 5 equals W, W equals 5, because they like to be very particular. Particular is a good word there. Okay. All right, so 1, our answer should be A. So let me scroll down here. All right, let's come down to question number 2, short answer. This question comes from lesson number 14, disproving conjectures with counterexamples. Okay, remember that in a counterexample, what we're looking for is something that proves or fits the hypothesis but does not fit the conclusion. Remember our guy from Putnam County, right? If my statement is all guys from Putnam County are good looking, we need a guy from Putnam County that is not good looking. Okay, that's a counterexample. I can't find a girl from Putnam County. I can't find a good-looking guy from Putnam County. Neither of those cases will fit. Neither can I find somebody from Scotland County, right? None of those 3 scenarios fit the hypothesis. Okay, show that the conjecture is false by finding a counterexample. If A is greater than B, then A over B is greater than 0. Normally, this would be a multiple choice question. All right, let's look at some statements where A is greater than B, but A over B is not greater than 0. This is more of a sample question than anything else, because notice that they don't give you a list of possibilities, which is sometimes kind of a goofy thing when you take away multiple choice answers, because if you'll notice in here, the answer in your answer key says A equals 11 and B equals -3, right? All right, well, you didn't have a multiple choice set of options to pick here, so really my answer could be anything where A is a positive number and B is a negative number, okay? Because anytime where A is going to be positive, right, we could make A 3 and B -3. Well, A would be greater, 3 is going to be greater than -3, okay? But 3 divided by -3 is -1, which is not greater than 0, all right? So any number that you would have given in this question where A was positive and B was negative would have worked as a counterexample. Okay, does that make sense? Okay. You also probably could have gone where A was any number, negative or positive, and B was 0. Why would that have worked? What's anything divided by 0? 0. Well, is 0 greater than 0? No, it's just equal to, right? So that would have worked as a counterexample because it would have meant that my inequality was still wrong. Okay? All right, so you could have gone with any number of possibilities there, okay, so long as that our hypothesis was true, but our counterexample was false. All right, let's see, let me scroll. I have to go over here and do it so it doesn't flip out. Okay, number 3, write the contrapositive of the statement, if a coin is a quarter, then it is worth 25 cents. Okay, what does a contrapositive do? Contrapositive, what does it do to a statement? Erica? Okay, it flips it and it negates it, right? And I think that's what you're saying there. Negate doesn't always mean to put in a not. We would put in a not statement where it's affirmative to begin with. But if it already had a not statement, we would take that not out, right? Okay? But you're not wrong here. So, what would I want to write for number 3? We want to start with if. Okay, if a coin is not worth 25 cents, okay, then it is not a quarter. Okay, that flips it because I'm taking my hypothesis, my conclusion, and moving it to the hypothesis side. I'm taking my hypothesis and moving it to the conclusion side, and we are negating it, okay, making not statements. That's going to do contrapositive. So a contrapositive is a mix of both a converse and an inverse. Converse flips, inverse negates. Okay, contrapositive has me do both. People have a tendency to confuse converse and contrapositive because they both start with a C. Okay. All right. That's 3. Let's see, number 4, an arc of a circle. Okay, so we're going to need to know our arc equations. We have 2 arc equations. We have area of the sector and we have arc length. An arc of a circle has an arc measure of 47 degrees. If the circle has a radius of 12.5 units, what is the length of the arc round to the nearest hundredth? So am I looking for area of a sector or arc length? What do you think? Heard somebody whisper it with confidence. For posterity.
Arc length.
That was Caleb Weaver, folks. Famous on the internet now. He's so proud. Okay. Arc length. Can you tell me what the formula for arc length is? All of like 5 people are going to watch that video, so I wouldn't worry about it. Arc length, who can tell me? 2 pi r. Well, let's start with just the formula, right? Okay, that's my arc length, right? And it's based upon circumference times a fraction. Okay? Let's see. Because you had said r, I just assumed that that's what we were starting with. Let's take our information and put it in. So I'm going to get 2 pi, what am I putting in for r? 12.5. And like you said, we're going to use 47 for my arc degree over 360. It wants it to the nearest hundredth. Normally what I use is I go ahead and I use the pi symbol because I'm looking for something that's exact. What the book ends up using a lot is 3.14 for pi. So let's do this. Let's pull up our handy dandy computer calculator. Okay, let's move that over so we can see what all we need to do. Let's turn it on, clear some stuff out. 2 pi, nope, didn't get it. 2 pi, there we go, 12.5 times 47 divided by 360. Now, what I'm going to do before I hit enter is I want to check my mode. My mode is in degrees. All right, that's what I want it to be in. So I get 10.25. Question number 4, I should get 10.25. And because all they gave me was units, they didn't tell me inches or anything like that, we can just say 10.25 units. And because it's arc length, it's just units, right? If it was area of a sector, we would square it because it's area, but this isn't. So just 10.25 for my answer there. Let's come down to number 5. Let's see, number 5 comes from lesson 21, laws of detachment and syllogism. Okay? Determine if the conjecture is valid by the law of detachment. Okay? Given, if Tommy made enchiladas tonight, then Tommy must have an oven. Tommy has an oven. Conjecture, Tommy made enchiladas tonight. This is made up of major and minor premises. Okay? Can anybody tell me in the given, what is the major premise? Brady? No. That's my minor, actually, in this case. My major premise. Well, process of elimination, Erica. Tommy made enchiladas tonight. This is the major, which if you like enchiladas, you understand. Okay? My minor statement is owning an oven. Okay? Minor. Okay? Now, I can only really make a statement based upon the major. I can't make a statement based upon the minor, right? Okay? Tommy has an oven. Making the conjecture, therefore, Tommy made enchiladas tonight. Let me ask you, have you ever used or ever seen somebody use an oven to make something other than enchiladas? I see people shaking their heads up and down. Well, you can't see that in the video, but they are. They agree with me. Okay? You can't hear it, but there's applause. People are excited. Okay? All right, so do you understand now, if we look at this, can you make, now granted, don't give me some situation where you're using a microwave to make enchiladas. You're living life wrong. Okay? Can you make legitimate enchiladas without an oven? They're shaking their head, no. No, you cannot. You should not. Okay? All right, therefore, that's why enchiladas is the major statement. So, our question was, determine if the conjecture is valid or invalid. Is this valid or invalid, folks? It is invalid by the law of detachment because it has me making my conjecture based upon the minor premise. Okay? If they had said, Tommy made enchiladas tonight, therefore Tommy owns an oven, we would have said that is valid. Okay? And again, somebody in the comments section below might say something to the effect that, That's not always true or something like that. About what I'm going to say next is that from my experience, the major premise in my given will always come first. Okay? They'll go major premise, then minor premise. Okay? So if I end up making my conjecture based upon the second half of the given, then it's probably invalid. Okay? All right. Watch out, you commenters. Don't forget to like, subscribe, and hit that notification bell down below. All right, find the area of a trapezoid. I'm having a lot of fun with this whole YouTube thing. Probably too much fun. All right, area of a trapezoid. What's the formula for that? I can tell you on question number 6, lesson 22, if you're looking for it. What? Ooh, close, but no cigar. Not base 1 times base 2 plus base 2. Base 1 plus base 2 times height, because we like to divide by 2 on area, right? We divide by 2 in area of a rhombus. We divide by 2 in area of a triangle. We divide by 2 in area of a trapezoid. So when in doubt, divide by 2. Okay? Base 1 plus base 2. Okay? In this, what is base 1? Right? I've got 3 or 6. You're both right. Okay? I typically put the top one if it's up and down. So we would get 3 plus 6. Let's make that a little bit more clear. Times my height. What's my height? 11. Let's not forget to divide by 2. 3 plus 6 is 9 times 11 is 99. 99 divided by 2 is 49.5 inches. What? Squared. Let's not forget our square. Okay, 49.5 inches squared. Okay. Hopefully we can cover at least half these questions. What did we say? We had 35. Okay, 35. So we want to cover hopefully right around 17, 18 questions today. Let's see. Harry and Selma start driving from the same location. Harry drives 25 miles due north, while Selma drives 60 miles due east. Due north and due east. What we're looking for is direct cardinal direction. So let's say that you're in Kansas or Illinois. This is pretty easy to do, right? Because it's all flat. There's no hills, right? And everything pretty much runs east and west, north and south, all right? So if Harry's driving 25 miles due north, Selma drives 60 miles due east, how far apart are Harry and Selma when they stop? They're not looking for if they stayed on the road, right? Because then we would just take 25 plus 60 and add those together and get 85. Anybody in here get 85 for an answer? Hopefully not. Because the picture that we want to draw is imagine that they're at an intersection whenever Harry goes 25 miles and then stops, and Selma drives 60 miles and stops. What's another name for the line that separates their distance? Austin? The hypotenuse. Because we're going to assume that based upon going due north and due east, that they separate at a right angle. All right, so what did you have to do in order to find the distance that they are from each other? We would say maybe as the crow flies. Brady? Pythagorean theorem. And how did you use the Pythagorean theorem here? Equals x or c squared, right? Okay, so 25 squared, I believe, is 625. Am I right? 625 plus 60 squared is what? Is that 3,600? Man, he's good. Everybody in the class said, but you can't hear them because they don't have mics. It's sad, really. All right, 625 plus 3,600. Is that 4,225? Yes. 4225. He can do big addition in his head. Okay. What is the square root of 4225? Something he can't do in his head? 65. Okay. When we square root both sides, they are 65 miles apart. Checking this question. Let's see where we're at here. We're at number 7. 7 is 65 miles. Okay, because we like including the units that they are from each other. Okay? How have we done so far on this review, just on your own as you've been checking it? Pretty good? Okay? Let's see. Number 8. Find the measure of each interior angle of a regular 45-agon. Can we draw 45-agons? That's a lot of sides to draw, and regular, so we have to keep all the angles the same, right? Find the measure of each interior angle of a regular 45-agon. How would I even begin? It would be so handy if there was a formula. Let's see, what is this? Question number 8. I bet that would probably be in investigation number 3 if it was anywhere. Jesus. Number minus 2 times 180. One more. Okay, so what this is going to give me, if I just left it there, would tell me the sum of the interior angles, right? Which we're only really one step short, because after we found that, once we found the sum of the interior angles, we would do what? Divide by the number of sides, so we divide by n. So let's go ahead and plug in our information. We got 45 minus 2, because that's going to tell me how many triangles I have inside of 45-agon, times 180, okay, which is going to give me all the sum of those different triangles, and then we're going to divide by 45. 45 minus 2 is 43. What's 43 times 180? Probably pretty. 7,740. My associate is telling me. Divided by 45 is what? 172. 172 degrees is the measure of each interior angle. Okay. Of each interior angle of a 45-agon. Those are some pretty big angles, right? In fact, the closer and closer you get to a circle, the closer and closer that's going to get to 180 degrees. Okay? Okay? All right, which we're pretty close there. 172 degrees. Make sure that when we're talking about degrees, we're using correct labeling, which in this case means using a degree symbol. Okay? All right. Let's see, number 9. Number 9. Okay, the diagram shows a new kind of triangular bread. That's really not necessary information. Where should the baker place her hands while spinning the dough so that the triangle is balanced? All right, question number 9 comes from lesson 32, altitudes and medians of a triangle. What we need to do is we need to find the medians of the triangle. Okay? First off, that means finding the coordinates of each vertex. In this case, I've got 1, 2. Over here, I've got 5, 1. Over here, I have -3, 0. Okay? Medians. A median is a midpoint of a line drawn back to the opposite vertex. Okay? All right, so let's find our midpoints. Okay, how do I find midpoint? I need to introduce either cricket sounds or Jeopardy music. Figure that out later. X sub 1 plus X sub 2 divided by 2, and there we go. I hear some people in the back. All right, so now we just need to plug in our information and find our 3 separate midpoints. All right, so we know that, so I'm going to erase it. Hopefully you got that down. Let's start with A to B. A to B, using our x's, we'd have -3 plus 1 divided by 2, and we would get 0 plus 2 divided by 2. Okay, what's -3 plus 1? -2, -2 divided by 2, -1. Yes. Which students? Oh, just these students. And it looks like, hey, there you are. I did my job. Okay, for watching the video, I have no idea what's going on. I just got a letter from the president. Took care of it. Okay, -3 plus 1 is -2. -2 divided by 2 is -1. On our other side, 0 plus 2 is 2. 2 divided by 2 is 1. So my midpoint over here is -1, 1. Hey, that's really nice. It comes out right there. Okay, and I'm going to go ahead and draw that line all the way across to the opposite vertex. Okay, thus giving me a median. Okay, all right, now we're going to pick a different set of coordinates. Let's go from B to C. So that's going to give me 1 plus 5 divided by 2, and 2 plus 1 divided by 2. 1 plus 5 is 6 divided by 2 is, all right. All right, 2 plus 1 is divided by 2, 1.5. Okay, so let's go 3 over, 1.5 up. Hey, look, that's right there. Draw that on over as best as we can to that spot. Right, that's my other median. Okay. And finally, we want A to C. A to C is going to be negative 3 plus 5 divided by 2, and 0 plus 1 divided by 2. Negative 3 plus 5 is, 2 divided by 2 is 1. Okay, 0 plus 1 is, 1 divided by 2 is, okay, could look at it like that. And so 1, oh, and that's going to be half. All right, so what I want is the coordinates of that final middle point there. And if you'll notice, it is 1, 1, which is going to be the center of that triangle in terms of having a balanced position. Okay, so 1, 1 is going to be our answer to that. Now, if you see this question on a test and it is a multiple choice question, will it be enough to say, yeah, the answer is 1, 1. I saw that on the review. Matt says, yeah, that'll be enough. And I say, no, you will not get credit for that. Okay? You must show work. And should you be able to show your work? Yeah, because I've got the video and I saw him do it in class and I know exactly what I need to do, right? All right, very good. At the very, very, very least, give me the 3 midpoints. Okay? Show me that you know how to find the midpoints. Okay? So do your midpoint formula 3 times, right? And draw me a rough sketch, right? That will work for me. Just show me that you know what you need to do to get there. Okay? Because that's really your work. Okay, number 10. Number 10, what time do we get out of here? Is it 48? Man, I've got plenty of time. Diagram shows parallelogram. We should know things about parallelograms. We have 4 rules for parallelograms. Rule number 1, opposite sides are congruent. Number 2, opposite angles are congruent. Number 3, consecutive angles are supplementary. Number 4, diagonals bisect each other, right? Okay, so those are the 4 rules we need to know and have written down. Right? If I could, I'd go back in and I would say it in slow motion for you. But you can go back and rewind this, play it over and over and over again until you finally get it down. Or you could look, let's see, question number 10 comes from lesson number 34, properties of parallelograms. Okay? All right, the diagram shows parallelogram-shaped component that attaches a car's rearview mirror, which is all unnecessary information, does not help us in any sense. RSTU, it says UR, okay, UR is 25. So let's go ahead and label that guy right there, 25. RX is 16. Angle M, or sorry, measure of angle STU. STU, this guy right here is 42 degrees. Okay, we want to find ST. Well, because I know the 4 rules of parallelograms and opposite sides are congruent, I know that ST is equal to RU, so therefore it is 25. Okay, XT, I know that diagonals bisect each other, so if RX is 16, then XT must also be 16. Okay, definition of a bisector. Right, and angle RST, let's use a different color. Angle RST, okay. Angle RST and angle STU are consecutive, right? Consecutive angles in a parallelogram are supplementary. The term supplementary means 2 angles that add up to 180 degrees. So let's say it this time, but with feeling. I can detach it. Austin Ziegler, what does that equal?
180 degrees.
There we go. With feeling and passion. Okay? Good job. Get all connected again. All right, so what we want to do is we want to take that 42, and I need to be more specific, it's 42.4. All right, so we're going to take 180 minus 42.4. What is 180 minus 42.4 to find out what that remaining angle length is? 137.6 degrees. is the measure of angle RST. All right, hopefully we've got that down. And we're scrolling. 11. Okay. 11 comes from lesson 36, right? Triangle congruence theorem. All right, and so we have triangle congruence theorems. We have things like angle, side, angle, side, 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 angle, side, angle, those types of things. We just need to remember not to cuss, so angle, side, side will not work. All right, but we also have different triangle congruency theorems based upon right triangles alone. Some of those include hypotenuse, leg, 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 angle. I don't know, there's one that I missed because there should be 4 of them. Okay, but you might want to go back and look at lesson 36 to go ahead and get those. For these triangles, we want to select the triangle congruency statement and the postulate theorem that supports it. This question on a test will give you multiple choice options. They're going to start off with, what is congruent to triangle ABC? All right, we want corresponding parts. So what corresponds to angle A? Angle J. What corresponds to angle B? K. And what corresponds to angle C? L. All right, so we want to start off right there. Now we want the correct theorem that supports it. All right, what is BC? It's a hypotenuse. Okay, and LK is also a hypotenuse. Do the two hypotenuses equal each other? All right, so hypotenuse and AC and JL are considered what in a right triangle? Are they angles? Are they hypotenuses? Or are they legs? Legs. So this is true due to the hypotenuse leg congruency theorem. Okay. This is not side angle side because we neither have that angle or this side. Okay, so it is not side angle side, it's not angle side angle, right? It is hypotenuse leg. Do not get confused. Okay? All right. Let's come on down to 12. May or may not be able to hit that 17 mark, but hopefully we'll be able to finish out in the other class. 3 towns, Mayberry, Junesville, and Siena will create one sports center. Where should the sports center be placed so it's the same distance from all 3 towns? Let's see, this is question number, 12. 12, and 12 is brought to you by lesson 38, perpendicular and angle bisectors of triangles. The answer here is treat the towns as vertices of a triangle. The center must be placed at the triangle's circumcenter. So you're looking for the circumcenter. Okay, that is the term. Okay. All right, so again, go back and look at lesson 38 for that. Number 13, okay, a homeowner wants to make a new deck for her backyard. Redwood costs $10 per square foot. The units on the graph are in feet. How much will it cost to create the deck shown? Okay, so we have a couple of different things here. This is what we call, we have a composite figure here in this. So lesson 40, finding perimeter in areas of composite figures. So we actually want to break this guy up into 3 figures that we can actually find the area of, right? My upper one, okay, this guy right here, 1, 2, and 3. What do we call that top figure right there? What's a name for that? No, a rhombus has all 4 sides congruent. That clearly would not be. More general. Parallelogram, okay? How do we find the area of a parallelogram? Maybe base times height, okay? Because essentially a parallelogram is a rectangle that's been kind of tilted over a little bit, right? So this one has a height of 3 and a base of 1, 2, 3, 4, 5, so it has an area of 15, right? What's the area of that rectangle? What is it, Matt? How do we find the area of a rectangle, Caleb? Base times height, so it has or length times width, has a width of 1 and a length of, So what is the area? 5. All right, what is the shape of the lower figure? Trapezoid, and we've already talked about how to find the area of a trapezoid. Base 1 here is 5. What's the bottom base? 7. What's the height? 2. 2 divided by 2. 5 plus 7 is 13. 13 times 2, 26. 26 divided by 2 brings me back to 13. All right, so we want 15 plus 5, which is 20. 20 plus 13, 33. Right? 33. So I got 33 feet squared. It's $10 per square feet. What do I want to do with that 33 feet squared? If I want to find out how much I'm going to spend, go ahead. Multiply by $10 per square feet. Okay, what is my final cost? Okay, $330. Okay, let's double check my answer there. Let's see if I'm right. 320. Did we miss something? Should have been 32 feet. Maybe 5 plus 7. 5 plus 7 is not 13, by the way. 5 plus 7 is 12. 12. So this should have been 12. 12 plus 20 is 32. Embarrass me in front of the entire YouTube community. I'm ashamed of you. Okay, so it should be $320 there. The viral following to peas. Okay, 14. We're closing out of time here pretty quickly. All right, write an inequality that gives the possible values for x in the diagram. Because these sides are congruent, okay, what we're looking at is the relationship between this angle and this angle. Notice that a 117 is greater than 48, so 3x minus 4 is going to be greater than 20 because it's opposite an angle that is greater. That's all the more that you really need on that, is 3x minus 4 is greater than 20. You can go ahead and solve that on down if you wanted to by adding 4 to the other side if you were trying to find the possible values of x, which I guess this does. So we get 3x is greater than 16, right? Oh, no, sorry, 24. 24. What's 24 divided by 3? X is greater than 8. So x is greater than 8. Okay? Can he get one more question in? We will see. Find the distance from 2, -1 to the line y equals 3. It's actually a pretty easy question because it is a horizontal line. The shortest distance between a line and a point not on a line is a perpendicular line. A vertical and a horizontal line are perpendicular by nature, so the distance there is 2. Okay? That's it. The answer is 2. Very good. 15. That comes from lesson 42, finding the distance from a point to a line. Can he do one more question? I don't know. Let's see. You guys are out of here at 48. I think he can do it. Okay. All right. Counterexample time. If possible, use the data in the table to prove the conjecture is false. If an element is a metal, then it is solid at 70 degrees Fahrenheit. We need something that is a metal but is not solid at 70 degrees Fahrenheit. Tungsten's obviously a metal. It is solid because it doesn't melt till 6,192 degrees. Copper is a metal, but it doesn't melt till 1,984 degrees, therefore it's solid at 70. Lead is a metal, but it's still solid at 70 degrees because it doesn't melt till 621 degrees. Mercury is a metal, but it melted at -38 degrees, therefore is it solid at 70 degrees? No, so Mercury is a counterexample. He needed to get to 17. Let's see if he can do it. Use the graph to write an equation of the line. The first thing we need is our y-intercept, which looks like -4. He needs a slope. Looks like, he's not going to make it. 1, 2, 3, 4, 5, 6, 7. Up 7 over 1. He would probably say y equals 7x minus 4. I don't know if that's right. Number 17, the answer is y equals 6x minus 4. It was really, really close. Thank you all for participating. We'll see you again tomorrow.